In this section, we're going to focus on solving trigonometric equations. Now, solving trigonometric equations isn't as cut and dry as a algebra equation is, where you have like x plus 2 equals 5, because you'll notice on a unit circle, sine or cosine can take on the same value depending on the quadrant. So if you're focusing on the entire unit circle always, things happen on a certain cycle. Remember that sine and cosine are periodic, 2 pi, and tangent is periodic, 1 pi. And so you'll get repeats, you'll get multiples. If you restrict your domain, it might be a little bit different, but we need to think about what happens with different angles. To account for these multiple solutions, let's look at a graph. Here is that sine graph that is periodic. And then the line of y equals root 3 over 2, that's when y equals root 3 over 2. You see that that happens at pi over 3, at 2 pi over 3, and then again after 2 pi, it repeats. And so we need to figure out a way in which to write our solutions. Looking at the unit circle, we see the same root 3 over 2 for y equals pi over 3 and 2 pi over 3. So every time our graph goes around a full period, you're going to get another location where y equals root 3 over 2. Every time you do it for 2 pi over 3, every time you do a cycle for 2 pi over 3, you're also going to get that. So this happens at 2 pi. Now remember that we're going to use n as an integer multiple. So here's how we would write our solutions. We would say that x equals pi over 3 plus 2n pi, and x equals 2 pi over 3 plus 2n pi. And this is on to infinity, negative infinity. You can do any integer multiple of 2 pi, clockwise versus counterclockwise. You can get any of those values. And so these are solutions for the real number system. But then solutions on an interval of 0 to 2 pi would just be pi over 3 and 2 pi over 3. Because it only happens at pi over 3 and 2 pi over 3 on the interval from 0 to 2 pi that y equals root 3 over 2. What about solving trigonometric equations involving multiple or compound angles? For example, it's not just a straightforward of when does cosine of x equal root 2 over 2? You're looking at something that involves more, looks like a more standard equation where you have, say, sine of x minus root 3 equals 0, something like that. So you need to write the solution set for a general solution, and you need to write a solution set on the interval. The first thing that you do when you're solving equations involving multiple or compound angles, you're going to isolate the trigonometric function. Once you've isolated the trigonometric function, then you need to determine what values make that trigonometric function true. When is it that sine of x equals root 2 over 2? Something along those lines. Now, if you're trying to find a solution on a given interval, you have to determine how many values it could happen in that interval. For instance, if you're talking about x equals pi over 6 plus n pi, meaning this is happening every pi, and you're looking at the interval from 0 to 2 pi, you want to try your values of n equals 0, n equals 1, n equals 2, and so on until you get past that 2 pi period. So if n equals 0, we have pi over 6 plus 0, or pi over 6. If n equals 1, we have pi over 6 plus pi, and that's 7 pi over 6, which is still less than 2 pi. If n equals 2, we have pi over 6 plus 12 pi over 6, or 13 pi over 6, which is too large. It's bigger than the interval. So the ones that work in this interval would be pi over 6 and 7 pi over 6. That's how you find your solution set on the interval given, and the one using the multiples is the general solution. Most of these values that we're solving, you're going to go to the unit circle for, and you're going to find when it's true on the unit circle at all values. So when is x equal to a half? It happens twice on the unit circle, and then you write your multiples. For a compound angle, that's when you have something inside the trigonometric function that's not just an x value. So you're going to need to use substitution in order to solve once you get your general solution to find out your actual general solution for the compound angle. For instance, let's say I had the sine of some value, x minus pi over 3, and that equals the negative square root of 2 over 2. Going to the unit circle to find out where the sine is equal to negative root 2 over 2, that's when the y value equals negative 2 over 2. That happens at 5 pi over 4 and 7 pi over 4. And then the general solution would be plus 2n pi because it's 2 pi periodic. But that's not x equals those values. That's x minus pi over 3 equal to those values. This is the same thing as like the sine of u equals negative root 2 over 2. Then u would be 5 pi over 4 plus 2n pi, or u equals 7 pi over 4 plus 2n pi.
But u is equal to x minus pi over 3, so you need to set x minus pi over 3 equal to the right side.
So x minus pi over 3 equals 5 pi over 4 plus 2n pi. And then you have to find what x is. So you wind up isolating the x that's inside that compound angle, which means you add pi over 3 to both sides of the equation. X is then going to be equal to, let's make this denominators of 12. 15 pi plus 4 pi is 19 pi over 12 plus 2n pi. And that is for the 5 pi over 4 value. You would do the same thing for the 7 pi over 4 value. So remember what you do is you find the value on the unit circle, then you set the inside of the trigonometric function equal to the general solution and you solve. The same thing is true for half angles. You isolate the trigonometric function, and then you find when that value is true, but you want to make sure that you're solving for the x only. So if you had x over 2, because you have a half angle, you would wind up multiplying both sides by 2, and that is the period as well. Say you have the sine of x over 2 equals 1. You know that the sine of x equals 1 happens at pi over 2. So this is saying x over 2 equals pi over 2 plus 2n pi. But then you would have to multiply everything by 2 to get rid of the 2 in the denominator. So you have 2 times pi over 2 plus 2 times 2n pi, which means that x happens at pi plus 4n pi. So you have to make sure that you multiply through the whole thing.